Okay, so we're on our second slide of section 2.1. I think that's right. Let me look and see what this said. Oh, 2.2. Sorry, we're on 2.2. I had to take a step away from the videotape for a while, and so I'm getting caught back up. So we're in section 2.2. We were talking about quantitative displays, so displays of quantitative information. The first part of the chapter, was categorical information. This is quantitative information. And so far we made a stem and leaf plot. Now we're going to make histograms, which look something like stem and leaf plots, except they're bar graphs instead of using the digits. It says, like a stem and leaf plot, displays histograms like a stem and leaf plot. So I should write this a little bit differently. Like a stem and leaf plot, these display the pattern of values found in the data. The word distribution refers to this pattern. So histograms are a way of graphing the distribution of the data set, which tells the pattern of values found in the data, just like a stem and leaf plot does. A stem and leaf plot, though, uses the actual digits, or at least rounded versions of the digits. So they contain a lot more information than these histograms do, as we'll see in a second. But overall, they're very similar things. Really, the reason for doing stem and leaf plots is just something you can do by hand without having to work too hard at it. This takes a little more work. You have to make some more decisions. Here we go. Construction. Divide the range of values in equal size intervals on a number line. So you're going to take a number line. You're going to say, maybe look and see where the values are in the number line like this. You're going to take some convenient interval on the number line. Then you're going to divide it up in equal size pieces like this. Equal size is necessary because later on we want the area of the bars to represent number of observations. The height's going to be the number of observations. If the widths are the same, then the area is proportional to the number of observations, which we always want. Then the intervals are called bins. So each interval is a bin. You say, well, how many bins did you use? Count the number of values in each bin. Okay, so here are 1, 2, 3, 4, 5, 6, 7 bins in this hypothetical example. The number of values is called the frequency. So in each bin there's a frequency associated with that bin. Make a bar graph of the frequencies. In histograms, the bars are adjacent to each other. So basically what's going to happen is you're going to have a bar over each of these intervals, counting how many values are in the interval. So here's some data we have here. Hours slept in the past 2 days. So roughly 8 hours a day, total of 16. Here are the data collected from some individuals. And then so we look at those values. They go from 12 up to 21. So I'm going to take an interval that starts here at 11.5, ends here at 21.5, just because I wanted to. And what's good about that is it's 10 units wide. So I can easily divide it into 5 parts of size 2. Okay, so these are all width 2, every one. So ordinarily you might just take an interval big enough to encompass your data where it's easy to divide it up into the number of bins you want to use. The number of bins you want to use is something like the square root of the number of values. I guess there's 25 values. Square root of 25 is 5. Hey, I lucked out. 5 is a good number. So roughly speaking, a square root of the values is a good number of bins to use in histograms. So we've got the exact number. Maybe slightly less is a better number, but it's an approximate number. And then we will count the number of values that fall between 11.5 and 13.5. So I have to find them. 11.5 to 13.5. So 12 is in there. 13.5. So between 11.5 and 13.5 is 12 and 13 are the only whole numbers. We only have whole numbers here. So there's 5 of them. So ordinarily I go like this. 1, 2, 3, 4, 5. Help you track it. Then 13.5 is 14 and 15. 1, 2, 3, 4, 5, 6. I write it that way because if I skip over one, oh, missed one. See that? 7. And then the next one is 16 and 17. Running out of symbols. I'll mark on top. 1, 2, 3, 4, 5, 6. That's supposed to be 16 and 17. Okay, and then this is 18 and 19 here. 1, 2, 3. There's only 18s. There's only 19s. 1, 2, 3. Any 18s? I don't see any. 3. Okay. 1, 2, 3. And then this is 20 and 21. Running on. I'll just put a little bar. 20 and 21. 1, 2, 3, 4. So I think there's a mark either above or below each of those numbers. Yes, so I think I got them all. So we look over here, the largest number of values in any of the categories, any bin, is 7. So I want to arrange this axis here so 7's near the top. 1, 2, 3, 4, 5. So I'm making a bar graph of the frequencies. There we go. So it says divide the range of values into equal size intervals, size 2. Intervals are called bins. Count the number of values in each bin. Here we go. Make a histogram, make a bar graph of the frequencies. Here's the frequencies. In histogram, the bars are adjacent to each other. Okay, so we just extend these up until they get to this height. So the first one is 5, so that'll be here. Second one is 7. Third one is 6. Then 3. And then 4. Not bad. So that's the process for making histograms. There are some issues that come up in histograms, but we'll encounter them at a later date. And that's pretty much the basic procedure, and everything is fine. We'll write on here number of bins, approximately square root, the number of values. Doesn't have to be exactly that. And then the bars are adjacent, that's important there. And there's what it looks like. And sometimes if you want to be fancy, you want to actually see the area. A little bit of shading sometimes brings out the area more than just making bars. All right, we survived another sheet, and let's move on to the next step.